is on Introduction to Nanomaterials. Matter and energy are manifestations of the universe. They exist in a variety of forms and interact with each other in many ways. Nano means 10 to the power minus 9. Nanometer is 1000 millionth of a meter. To understand how small 1 nanometer is, let us see few comparisons. A red blood cell is approximately 5000 nanometer wide. Water molecule is almost zero point 0.3 nanometer across. Human hair, which is about 100,000 nanometer wide. The design which you can see on the glass is painted by collided solution of 86% gold and the 14% silver, because of which when the light is incident, the change in response of the light takes place. Now, when we see the second picture in the calendar, there again red circle is produced due to gold nanoparticles. This is the history of nanoscience. Even when we use kajal and Ayurvedic bhasma since very long, their utility through metal nanoparticles. What is a nanometer? Nanometer is 10 to the power minus 9 meter. The size of human hair is of the order of 10 to the power minus 6 meter, that is approx 100 micrometer, and the size of red blood RBC 5 micrometer, and the size of coin 2 centimeter, and the size of raindrop 1 millimeter. Nanozone started from 1 nanometer to 100 nanometer. In this figure, gold particles 13 nanometer to 15 nanometers, bacteriophage 60 to 70 nanometer, and flu virus 100 nanometer, and the diameter of DNA 2 nanometer. What are the nanomaterials? Nanomaterials could be defined as the material with at least one of its dimensions in the range of a nanometer. Thus, the material need not be used so small that it can be seen. It can be a large surface or a long wire whose thickness is in the scale of nanometers. Nanomaterials that are nanoscale in the one dimension are layers, such as a thin film or surface coatings. Nanomaterials that are nanoscale in two dimensions include nanowires and nanotubes. Carbon nanotubes can be considered as cylinders made of graphite sheets, mostly closed at ends. The thickness of sheet is just the atomic size of carbon atom and area about a few square micrometer. It is also possible that many concentric cylinders may form as a nanotube. Such nanotubes are termed as multi-wall carbon nanotubes. Materials that are nanoscale in three dimensions are particles, for example, precipitates, colloids, and quantum dots. This is carbon nanotubes. Carbon nanotubes is about 1 upon 50,000th the width of a human hair. Carbon nanotubes are made by rolling a sheet of carbon molecule upon itself to make a pipe shape. Cable made with nanotubes could even be used in the construction of space elevators. This is multi-walled carbon nanotubes. The one illustration above can be 15 to 20 times stronger than steel and 5 times lighter. They are amazingly strong for their size and they conduct heat and electrical current with ease. There are different bottles having different size of nanomaterials. It emits light at different frequencies. And the size of the nanomaterials from 2.3 nanometer to 5.5 nanometer, and they emits different frequencies of light. What is nanoscience? Nanoscience can be defined as the study of phenomena and manipulation of materials at atomic, molecular, macromolecular scales where properties differ significantly from those at a larger scale. Nanoscience is the study and understanding of properties of nanoparticles. What is nanotechnology? Nanotechnology can be defined as the design, characterization, production, and application of structured devices and systems by controlling shape and size at a nanometer scale. Why properties of nanomaterials are different? The properties of nanomaterials are different from those at large scale. There are two principal factors. One is increased relative surface area and second is quantum confinement effect. These factors can change or enhance properties such as reactivity, strength, and electrical characteristics. Increase in a surface area to volume ratio. Nanometer materials have a relatively large surface area when compared to the same volume or mass of the material produced in a larger form. Let us consider a sphere of radius r. Its surface area is 4 pi r square, its volume 4 by 3 pi r cube, and the surface area to volume ratio is 3 by r. Thus, when the radius of the sphere decreases, its surface to volume ratio increases. Thus, we define that when the given volume is divided into smaller pieces, the surface area increases. Hence, as particle size decreases, a greater proportion of atoms are found at the surface compared to those inside. Nanoparticles have a much greater surface area per given volume compared with larger particles. It makes material more chemically reactive. Quantum confinement. In nanocrystal, the electronic energy levels are not continuous as in the bulk but are discrete. Because of the confinement of the electronic wave function to the physical dimensions of the particles, this phenomenon is called quantum confinement, and the nanocrystals are also referred to as quantum dots. Properties of nanomaterials. Nanomaterials have properties that are different from those of bulk materials. Most nanoparticle materials are crystalline in nature and they possess unique properties. First one, physical properties. Physical properties of nanoparticles are: crystal structure of nanoparticles is same as bulk structure with different lattice parameters. The interatomic spacing decreases with size, and this is due to long-range electrostatic forces, the short-range core-core repulsion. The melting point of nanoparticles decreases with size. Chemical properties. The electronic structure of nanoparticles is dependent on its size, and the ability of nanoclusters to react depends on cluster size. The large surface area to volume ratio, the variation in geometry, and the electronic structure of nanoparticles have a strong effect on catalytic properties. Electrical properties of nanoparticles. The electronic structure of nanomaterials is different from its bulk material. The density of the energy states in the conduction band changes. when the energy spacing between two energy levels is more than the kBt energy gap is created. Nanoclusters of different sizes with have different electronic structure and different energy level separations. The ionization potential at nano sizes are higher than that for the bulk materials. And the magnetic properties are the magnetic moment of nanoparticles is found to be very less when compared them with its bulk size. Nanoparticles made of semiconducting materials, germanium, silicon, and cadmium, where cadmium are not semiconductors. Thank you.